Welcome to the Gardien Group podcast series. The Gardien Group, providing extraordinary solutions to today's exceptional problems.
Hello, and welcome to another slice of the Gardien podcast series. I'm Todd Colding, your host. Today we're going to talk about high voltage, insulation resistance, and Hipot testing. The differences between those. Rick Murrah is usually with me, but he's on assignment, so I'm having a little color commentary from an AI fill-in today. We'll see how that goes. So with Hipot IR testing, what we're looking for is metal inclusions, splinters, dips, things that cause inferior responses between layers or nets in the dielectrics, causing shorts to appear. A lot of times these might be appearing later on in the duty cycle if they don't appear right off the bat, and that causes latent defects in the field, which is definitely something we don't want. So let me talk a little bit about what the differences are before we move on forward understanding this. IR test and Hipot are both provide the insulation and isolation test. The difference is more with Hipot, it specifically measures breakdown in the dielectrics. It's a straight go or no-go type of test where you have a stimulus probe and a listening probe, and you apply the voltage and look for any leakage in the dielectric. And sometimes this could be on the same layer, or it could be on layer to layer. The IR test, though, is a hybrid of the Hipot test. Does the same type of thing with the voltage and listening, but it also validates using a high resistive threshold to make sure that the dielectric itself is withstanding the required isolation. And a lot of times this could be up to 500 megohms or even a gigohm at certain, depending on the application. So the first thing we're going to do is talk about IR tests. This is the insulation resistance test using the isolation resistive threshold. And with that, I'm going to let our guest AI speaker talk about that.
Thank you, Todd. There are two types of Hipot test: standard dielectric breakdown and insulation resistance testing. Both can be high voltage, but there are differences between the tests. First, let's talk about IR testing. A modern megometer, or megohm meter, applies a DC voltage to a DUT and measures the DC current, nanoamps or microamps. Applying Ohm's law, the corresponding resistance value is then shown on the meter's analog or digital display. This instrument is often called a megger, which is a term trademarked by the Megger Group in 1907. In a typical megometer, the user can select from several voltage levels. For cables or equipment with rated voltage up to 500 volts, the maximum DC test level is usually twice the rated voltage. Above a 500 volts rating, the maximum level is closer to the rated voltage, for example 5000 volts for a 4100 volts system. The equipment manufacturer may have more specific test recommendations. Due to capacitance and dielectric effects in the DUT, it takes time for the reading to stabilize after the voltage is applied. Initially, the reading is dominated by capacitance charging. Absorption currents may be significant for 20 seconds or more. Usually, IR readings are made after 60 seconds to allow these effects to settle out.
All right. Thank you for that bit of information. So what did we learn here? We learned that the IR test can be AC or DC. We talked about before was the IR test validates the isolation between planes or nets, but we use a resistive threshold, which referees whether the DUT or device under test passes or fails. Remember, that's different than the actual Hipot. Next thing we want to talk about is the actual Hipot test, which is, I mentioned earlier, the go, no-go when you're checking the dielectrics, and this could be plane to plane or net to net, or even net to plane for that matter, but we're just going for a leakage check to make sure that the dielectrics hold up. And I'll send that back over to our AI guest for some commentary on the Hipot test.
Thanks again. A Hipot, short for high potential test, determines the ability of electrical insulation to withstand normally occurring over voltage transients. The Hipot tester applies high voltage to the insulation barrier of the DUT and verifies there is no breakdown. It is a simple pass or fail test performed as a type test on a representative sample unit or as a routine production test. Maximum allowed leakage is usually in the range of 0.1 to 5 milliamperes, or as specified in the test standard. The actual leakage value for each DUT may be recorded for quality assurance. Many standards, such as IEC 60950, specify an AC test voltage that is twice the operating voltage plus 1000 volts. Most allow the use of either AC or DC voltage. The test setup and procedures are identical for AC and DC, although the DC level should be equal to the AC voltage peak. The test time is normally 1 minute, but in some situations, such as high-volume production testing, a shorter test time may be permitted at a higher voltage. Typically, a Hipot test is performed on the voltage planes of printed circuits. One probe of the tester is connected to one plane. The other probe is connected to another isolated plane. If leakage is detected, the test will abort immediately.
And once again, thank you for that. We learned there, Hipot test specifically measures the dielectric breakdown. It can either be an AC or a DC voltage, and although he did mention a specification in his commentary, the other specification that is more specific to printed circuits is the IPC TM650 Test Methods Manual, which is used for refereeing in Hipot and dielectric tests. With the TM650, we have a couple of different cases. We have test scenario 1, which is a basic 500 volt test, and then we have test condition B. Condition A, 500 volts, and then we have condition B, which is 1000 volts, and the ramp and dwell times can be changed on these two different test conditions. And now that I'm mentioning dwell time, let's talk about a couple of terms. When we talk about this type of test, we have a voltage, which is kind of self-explanatory. This is the AC or DC voltage used for the test. We have a term called ramp time, and this is the time set that the system will go from 0 volts to test voltage, depending on what your test voltage may be. And as TM650 suggests, ramp time should be 1 second per 100 volts. So if we use an example of 1000 volts to do the Hipot or IR test, we want to ramp that up 100 volts per second. So it'll take us about 10 seconds to ramp that up. And we do that for a reason of safety. The main reason is that if we do have a problem in the dielectrics, as we start to ramp up, the system is watching that, and if we see any leakage detected or a short, immediately the system will fault at that point, and we won't even get up to test voltage, so that there won't be any significant damage to the PCB or an arcing that could be hard on the equipment, or if it was a manual test, the operator, if they happen to be close by. The other thing is dwell time. This is the time that the test will remain at voltage, at the high voltage, and while taking readings. So we've gotten through the ramp time up to 1000 volts, and now we're going to hold that 1000 volts for the dwell time, and TM650 suggests we use a minimum of 30 seconds for automated equipment, longer for manual test as necessary or as specified by the customer documentation. I can't really stress that enough. When the specifications, they say the suggestions, but if a customer drawing or a procurement document has some other ideas for those variables, you need to take those into consideration, especially when we're talking about military, aerospace, and medical high reliability equipment. A lot of times that dwell time might be a lot longer, and we might ramp a little bit quicker, but there's some there is some options there, but the TM650 gives us some general guidelines of what we should do if we're brand new to that type of test. So we talk about equipment and tools that are available out there. Most Hipot and IR tests are done by using meters. They're specifically designed for doing the Hipot or the IR testing. Gardien is well equipped to handle that. We use meters. We can do both the on-the-bench type of tests, and we build fixtures for those, and those are specifically for larger boards. If you have a larger board with multiple planes or different nets, pairs that need to be tested, and when I mean pairs is you have a probe, a stimulus side, and a listening side. Sometimes you have multiple planes, and sometimes you have arrays where you have multiple boards on arrays and you have to test those all at one time. We have developed and we built switching fixtures, which those are designed to provide the test, and if there is a fault, you can use the switching matrix on there to shut off different planes, or in the case of an array, you can shut off different images in the array so that you can isolate which image in the array is bad, or you can isolate which plane is shorting to which plane on a larger board. So that's the on the bench type of test. The Gardien flying probe line can also perform this test for you. This is done by an integrated meter into the system itself, so it can do the opens and shorts general test along with an IR or Hipot test, and this can all be done in one session without having to remove the board from the machine and go to a bench type scenario, or even on the same machine having to reload programs, and that can introduce possible errors in handling. So with our flying probe systems, we can do a lot of buried or additive tests, such as varied passives, inductance, capacitance. We can also do the IR and the Hipot test as I specified. This is all available on the equipment, and this is just a matter of if you're deciding to procure equipment, what options you would like to have on that piece of equipment when it's delivered, and this can also be done as an upgrade so that you can do all of the magical tests in there. It's all specified in the PO when the machine is procured, and then it's just licensing stuff after that. So if you want to get in touch with our sales group, info@gardien.com or sales@gardien.com, they can definitely give you an idea of what it would cost you to get yourself into that arena. But then again, we also supply the service at any of our service centers where we can provide the Hipot test or IR test, buried capacitance, buried resistors, coils, all that stuff can be done at our service centers if you need help from us. So give us a look up there. So with that, that kind of wraps up what we were going to talk about for today. The IR versus Hipot, we talked about that. We kind of explained more in depth what the IR test is. We also explained more what the Hipot test is. And then wrapping up there, we talked about our options and solutions for your needs, whether it be flying probe equipment for your site or sending your product into us to get those tests done, which we can do either on flying a probe equipment, or we can develop the switching type fixture, which we can test arrays and multiple pairs on bigger boards, which, by the way, we can do that as well on the probers. But with the switching fixture, it does give us a little bit better idea of how to isolate a fault if it does show up during the test. So with that, I thank you for sitting here with me today and listening to Hipot versus IR. And now that I mention it, the high voltage part of it, some people get confused between the IR and the Hipot, and then they say high voltage test. Well, when we talk about high voltage test in ET, a lot of times we're talking just higher voltage in the standard ET opens and shorts, where you're doing a voltage and an isolation and a continuity check all at once. And we can do high voltage there, but what we're doing only is just high voltage, meaning that we're running at higher than the standard test of a 9252, which is a lot of times 100 volts standard. And then on the class 3 level C testing, we get up to 250. And above that, we can go to 500, and our probers can go up to 1,000. But this, not to be confused with the IR and Hipot. We don't use any ramping time and dwell time. This is just using the high voltage for looking for shorts, and that is an instantaneous test. So when you're looking to explain to us or to wherever you're having your test done, need to specify the difference if you're looking for IR with the insulation threshold resistance, or Hipot, which is the standard dielectric breakdown, go, no go, or if you're actually looking for a just high voltage ET, because some of the electrical testers out there, fixture testers, sometimes can't go up above 250 volts. But probers can get up there. We can get ours up to 1,000, and so we'd be glad to help you with that. So just remember that, and always pay attention to your procurement docs or the fab drawings, because they may call out a special specification such as the TM650 condition A or B, or they may have a specific requirement for voltage, whether AC/DC or whether it's a longer ramp time and a longer dwell time. So always be making sure that you get that information correctly to your service bureau or to us, to any of our service centers, so that we can get the test done correctly and have proper information for you on the certificate of compliance. As always, if you want to look us up, just get on the web and look at www.gardien.com. That's www.gardien.com, and also send us an email at info.gardien.com for any general inquiries. And if you're really looking to get into some equipment, look at our equipment tab on the web page, and you can always send email to sales@gardien.com. So with that, I thank you all for sitting with me and listening to the world of Hipot and IR testing, and I'm glad you took time out of your busy day. So until next time, I hope you all have a great rest of your day and week, and we'll look for you on the next Gardien podcast. Todd Comening from Gardien. We'll catch you next time.